A computer can feel fast one moment and sluggish the next, and a lot of people blame the wrong part. The processor gets all the attention, so it is easy to assume the CPU is the whole story. But that is only half the machine. The real trick is that a computer is not just trying to think quickly, it's trying to keep the right information close enough to the CPU so the whole system does not slow down waiting around like a disorganized office with one overworked employee and a mountain of paperwork. That temporary workspace is RAM, and once you understand what it actually does, the way your computer feels starts to make a lot more sense. RAM is not storage. That's the first thing that trips people up. Your SSD or hard drive is where files live long-term. Your photos, games, software, downloads, and operating system all sit there until you need them. RAM is different. It's a short-term workspace where the computer keeps the things it needs right now. When you open a program, the computer doesn't keep running back to storage every second to fetch tiny pieces of data one at a time. It pulls the useful stuff into RAM so the CPU can get to it much faster. That's why RAM matters so much. It's not there to keep your files safe, it's there to keep your computer moving. And this is where the second misconception starts to fall apart. People often say more RAM makes a computer faster, and that sounds simple enough, but it's only partly true. More RAM does not magically speed up every task. What it really does is give the system more room to keep active data close at hand. If your computer is constantly running out of space and having to swap information back and forth from storage, everything starts to feel heavier. Open too many tabs, launch a game, keep a video editor running, and suddenly the machine starts acting like it's carrying too much in its head at once. RAM is what stops that from happening too quickly. That's the interesting part. RAM is not the star of the show, but it is often the reason the show doesn't collapse. The CPU is fast, but it's also impatient. If it has to wait for data to crawl in from storage every time it needs something, all that speed gets wasted. So RAM steps in as the middle layer. It's far faster than storage and much closer to the CPU in practical terms. It holds the active data, the open programs, the temporary working files, and everything the system needs to keep the next action ready before you even ask for it. If you enjoy seeing how these hidden systems actually work underneath the surface, this is exactly the kind of thing this channel is built around. The parts that look simple are usually carrying more responsibility than anyone realizes, and RAM is one of the best examples of that.
The weird thing about RAM is that it forgets everything when the power goes off. That sounds almost like a flaw until you realize it is the entire point. RAM is designed to be temporary. It is built for speed, not memory. It needs electricity to hold information, which means when the computer shuts down, everything inside RAM disappears. Not because the data is broken, but because the workspace itself was only meant to exist while the machine was awake. That is why saving a file matters. Saving moves information from temporary working memory into long-term storage, where it can survive after the power is gone. So RAM is basically a stage where the computer keeps the current performance in motion. The CPU grabs instructions and data from it, uses them, and then moves on to the next thing. If the stage is small, the computer has to keep clearing and replacing what is there. If the stage is bigger, more active work can stay ready at once. That is why system memory affects the feel of a machine so much, especially when you are multitasking. It does not make the software smarter, it simply gives the software more breathing room. But RAM also has a hidden limit that people rarely think about. At some point, even adding more memory stops helping much, because the computer can only use what it actually needs. If your tasks are light, extra RAM just sits there waiting. If your tasks are heavy, too little RAM becomes a bottleneck. That is why memory is all about balance. A fast CPU with too little RAM can still feel choked. A large amount of RAM with a weak CPU can still feel slow. Good performance is not one magical part, it's the coordination between parts. And that's where RAM becomes more interesting than it first appears. It's not just a number on a spec sheet. It's one of the reasons your computer feels responsive instead of constantly hesitating. Every time a program opens quickly, Every time a tab stays alive in the background, every time your system switches between tasks without freezing, RAM is part of what makes that possible. It's the working surface where the computer keeps the moment alive. So when people talk about RAM like it is just extra speed, they're missing the real story. RAM is not the engine, it is not the storage, it's the temporary workspace that keeps the CPU from starving every few seconds. It exists so the machine can keep active work close, fast, and ready. And once that clicks, the whole computer stops feeling like a black box and starts looking like a system with clearly divided jobs. That's RAM in plain terms. Not permanent memory, not storage, just the fast, forgetful workspace that keeps your CPU from starving.